Hi, welcome back to Academic Market Insights. I'm Professor Russell Rhodes, joined by Dr. Larissa Adamiec up the road at Purdue University. She is teaching risk management in the spring of 2026, and there are a couple of topics she wants to reinforce for her students. One of them is conditional variance, as you can probably tell by the title of this video. So with that, I'm going to hand things over to Dr. Adamiec. She's going to just spend about 10 minutes or so on conditional variance, and if I feel like chiming in, I might. Go ahead, Larissa.
Dr. Rowe, I think you're going to like conditional variance. This is a topic right up your alley. You're very much interested in variance and volatility. So we're going to do a couple of things first. We've got about 10 years worth of data here for SPX. Let's go ahead and graph this data. So we're just going to do some basic visualizations of the data. Let's go ahead and put our horizontal axes in because, it helps. So we're taking a look at it. Okay, and we'll just say SPX. And then just because of who I am, I'm going to change that, cut this, and put it at the top of our worksheet. And we're going to talk a little bit about what we're seeing in this data. So we can see 2001, we see a bit of a crash down in 2005. Then we see this nice, long, steady rise in the overall market, crash from the 2008 financial crisis, and we see a nice peak back up. Now, we're very much interested in the true volatility. So we're going to go ahead and calculate returns for the data, and then we're going to look at what the returns data looks like, and then we're going to calculate some descriptive statistics before we get to our conditional variance, just so that we can have an idea of what we're looking at and talking about and figuring out why we would even care about this topic. So let's go ahead and look at returns. So we'll use a percent return as opposed to a continuous distribution where we use natural log. So we'll use discrete returns. And we're going to go ahead and chart this as well. Let's go ahead and do that. And let's go ahead and add in our date. Oh, we gotta start one lower. Okay.
That is a mistake I almost always would make.
It's hard, right?
Yeah, when you're skipping the first date. Yeah.
So let's again go ahead and put it up here. So again, we were in our first graph that we look at, we're looking at just the straight price data. Now we've got the actual returns, and returns we use because it allows us to compare apples to apples. So for example, if we're comparing stock Apple to maybe McDonald's, they're going to have very different price points, and it makes it very difficult to actually compare them, which is one of the reasons why we use returns. So I'm making this smaller just so it makes it easier to see on the chart itself. And we can see how these kind of go together, right? So we've got a top layer. We've got much more variance or variability during the crisis. During this nice long bull run, we kind of don't see a lot going on, right? So let's go ahead and calculate. So we can see visually what's going on here, and we can see the spikes and returns and how they correspond. But let's go ahead and calculate our descriptive statistics. And we're going to do them on our returns itself. So we're going to do mean, and we're just going to do mean and standard deviation. And mean is the average function, I think. And we're going to use, so we have two choices, standard deviation population or standard deviation sample. Because we are using so much data, we're using daily data for 10 years, population is sufficient. It is technically a sample. So technically we should be using the S. However, because our population or our sample is so large, it's statistically insignificant which one we use.
When it's smaller, you want to use
Mhm.
the population. And one of the textbooks we teach out of or have taught out of, because I know we both taught the same class using the same book, they use the sample on a 4 return observation.
Wow.
And I know, and which causes a big headache for me because and then the rest of the book uses population. And that's what happens when different authors write different parts of a book, I guess.
Yes.
But it's been a consistent headache for me. But I just feel like if you always use population, you're in good shape.
Mhm.
Just
So we have what we would expect for our mean and standard deviation from this time period. There's nothing too exciting. But let's talk about this further. And I'm hoping to get a little bit of a conversation started about this. Dr. Rowe, if we're
mm-hmm,
trying to predict tomorrow's volatility, okay,
mm-hmm.
do we care about what happened in 2001, 2002, 2003?
Not that far back,
Maybe,
but
maybe not, right? Will we
right.
care more about maybe last period's volatility?
Maybe the last 20, 50,
Maybe.
something along those lines. It really, part of it depends on what's going on. In 2008, I might look at 50. Right now, I might look at 20.
Right. So, but the point is, and I appreciate you even saying that the different time periods,
Right.
we're going to have different preferences for how we're going to do a look back for prediction. Okay.
Mm-hmm.
So, one model, and this is just a model for a conditional variance. There's lots of different ways we can do this. We're going to take yesterday's variance and multiply it by 0.94 and add it to the returns squared, oops, times 0.06. So we're looking at two factors. We're looking at yesterday's uh, variance, and then we're looking, or standard deviation, pardon me, and then we're looking at the return squared, and we've got a weight. So there's a 0.94 for the yesterday, and then 0.06. And the objective behind this is so that we have a better understanding of what could be the true volatility for that day. So again, these are prediction models, and we're now incorporating different data to be in here. And if you're looking to develop even further models, that's when you would look at maybe the GARCH. And we do have a video up on GARCH, and so that we can have better ideas for incorporating different types of data and then having them weighted differently. So we
Just
can go,
real quick. If you're interested in the Garch video, I'll put a link to it in the description. So
yay.
yeah, so you don't have to go searching if Dr. Adamiec just said, we have a Garch video, and you're like, oh gosh, I need to watch that, and you scribbled it down. The link is in the description just below where we are right now.
Excellent. And so now we can go ahead and calculate. Again, this is just the conditional, and it's conditioned on yesterday's activity in the market and then today's returns. So the look back period is actually very small. We could do rolling averages. We could look at 20-day periods. We could look at 5 days, 10 days, 100 days. There's lots of different ways we can go about doing this for different look back periods. But this is just a start down this idea of calculating conditional variances for predicting the proper volatility. And with that, we thank you for sticking with us. Thank you so much for watching our video at Academic Markets Insight on conditional variance. If you like this video, please hit like, and if you haven't already, please hit subscribe. Thank you.